Hey everyone, I'm glad to be here. This is going to be one of those, after that inspiring talk by our professors on the future, which lies in our students, I'm switching gears. It's going to be the Monty Python, and now for something completely different. I'm going to talk about some of the work that I'm doing in my new job. I went from being the Assistant Director for Environment at the City of Dallas to the Director of Environment and Development at the North Central Texas Council of Governments. For those of you who don't know what that is, it is a voluntary organization of the 16 counties in and around DFW. So it's a lot. It's over 200 cities. We work with anyone that will answer our phone calls. And so since I know many of you are doing other things, I'm going to be talking about drainage. And even though it's water, for many it can be kind of a dry subject, but it's been a challenge that we've had in our region for ever since we've ever been here. If you think about it, people locate civilizations where there's transportation and water. And guess what? When you start building in those locations, you get more water, which leads to flooding. And so we've done a lot over the years, but as we look around the region, y'all, we got 200,000 people move into DFW last year alone. We've had similar numbers the last 5 years. That's 1 million people. That's 5 cities of McKinney in 5 years. That's a lot of people. We don't necessarily have the infrastructure to support that. And so I want to share some of the work we're doing right now to try to build smarter, not harder, moving forward. So it's a project. TSI is a very short acronym. We like acronyms in my world. It is for the Upper Trinity River Integrated Transportation and Stormwater Infrastructure Initiative, TSI. And so what we're looking at is my engineering friends. The transportation department is in one room. The environmental folks are down the hall. And the drainage folks are someplace in the middle. And my gosh, it would be a major hurricane if the 3 groups ever talked together. And so one of the main themes of this project is to integrate those 3 practices as we develop. So it's proactive, looking ahead, rather than reactive. Oh shoot, we have too much water and there's no place to go. I guess we better build a tunnel. So, and it's a regional approach. We're looking at it as a system. So it's about $10 million in grants, but we have local funds. We also have local agencies working out of their own funding. It is a comprehensive planning study. And you will look, it's generally for the areas west and north of DFW where the water's coming from. And guess what else is happening out there? That's where part of those 200,000 people per year are going. And so it's like, well, if we completely build that out the way we've built out Fort Worth, Arlington, Dallas, the infrastructure, the existing infrastructure in those existing cities does not have the capacity to address the additional runoff. So it's a proactive project. It is to integrate stormwater, environmental, and transportation infrastructure. And we're largely, if somebody asks us why we're doing it, it's public safety, it's community health. We are rapidly building. Remember I told you this is a dry subject? We're doing a lot of modeling, a lot of 1-dimensional and 2-dimensional modeling. We're re-looking at flood hazard areas. We're jacking up the rainfall to reflect what's really happening. Because in case you haven't noticed, I don't know, I got 2 inches the other day in a period of about half an hour. That's not normal. So we have some changes in weather over time. We're also, because we've been working on this for about 2 years now, and after the July 4th floods in the Hill Country, got a phone call from my director saying, okay, what are we doing here to prevent that kind of flooding from happening here in DFW? And it turns out we're doing a lot, but one of the big things is flood warning systems, where you look at the rainfall amounts and you look what's going on with respect to water levels in your channels and start getting people out of the way before they're in trouble. So we're doing that. And the other thing is, and this is a lessons learned, we also are doing a climate pollution reduction grant project for the region, otherwise known as a climate plan. We're calling it an air quality improvement plan because, what do you know? The air quality parameters that we're worried about with respect to compliance with the Clean Air Act are the same general sources that we find for greenhouse gas reduction. And so it's an air quality improvement plan. When we went out to the communities to get ideas on what to put in that plan, a full 82% of the respondents, that's east and west, it's north and south, it's urban and rural, 82% of the respondents requested more green space. And so because of the benefits that green space provide, particularly nature-based solutions with respect to slowing that urban flood pulse, our projects are going to include a lot of green space. And then 200 of the cities in that storage area, the average size of those cities is 2,000 residents. Those cities have a mayor that's also the police chief. Some cities have a track coach that's also the city manager. They all wear multiple hats. None of them are drainage engineers. A lot of them have had the classes to become their floodplain administrator, but a lot of them really, really need resources. They need help. They need guidance. So we're developing the models and we're developing libraries. We're giving them really good, it's a good library on flood ordinances for multiple size cities so they can find something that fits what they want to do. Lots of resources on flood warning systems and lots of warnings, not warnings, warnings, yes, you're gonna flood, but lots of information on basically how to put together a stormwater program. So we've got lots of partners, and that makes contracting and project management challenging, but it's also very rewarding, because if you want to do everything, the experts are in the room. And they're saying, hey, let's do this and this and this. Hey, we need to look at this. We've pulled in Highland Economics that does environmental return on investment so that we're making the economic case for the project. And we have consultants. There's a whole lot of modeling. There's a whole lot of, like I said, it's a pretty dry subject, but I think it's an important subject. So the other thing is that many of you know one of the things that the COG does is we do population projections. So on the left-hand side, that's where we're at in 2030. And on the right-hand side, that's where we're looking to be in 2050. As you can see, we've gotten a whole lot redder. That's that 200,000 people per year. The challenge is that when we put that many people in roads and homes and houses and businesses, we get a whole lot more runoff. And so what we're trying to do is incorporate solutions to that runoff to mitigate flooding from that growth as we go. So one of the other things that we have found is most of the places in Texas where we've had fatalities related to flooding are also related to roads. And most of the places where you get significant damage that impacts the community, it's flood infrastructure at roads. And so we're really kind of focusing in on that. Rebuilding cost, schedules, all of that can be hard. And so we're trying to prevent that. The other thing is that the upstream development that you and I only see if we decide to take a road trip out to Weatherford, impacts DFW, impacts the built environment throughout the Metroplex. And so we're really trying to proactively address this. Most of you guys know this, urbanization increases flood risk. And it's basically a matter of more water. And we're putting homes and businesses places that may be prone to flooding. The other thing that's really interesting is some of the aftermath from Hurricane Harvey. There was a really nice graph, it's figure number 5 in the after Harvey report, shows an increase of 40% damages in areas that are not in the floodplain. In other words, it's flooding where it theoretically shouldn't be. And so that's the other thing that we're trying to do, and that's the place where green space gives us some help, is that we've got places for the water that got to go other than people's homes or businesses. So I think we've already talked about this one. So one of the things I told you we were doing a lot of modeling, and I'm going to try to get through this without getting too geeky. But one of the things that we're looking at, there's 2 things when you look at changes to how a watershed responds to more water. One is the volume of water itself. The other is the time it gets to go from the very top of the watershed to the bottom. So if you can slow that water down, you don't have as much to deal with at any one time. And so that's another place that we're looking at. Okay, let's not just put rain barrels everywhere. Rain barrels don't really hold enough to do much good. Let's not put detention everywhere. Where we turn that question around, where do we get the most bang for the buck for adding storage? And so that's where we've done a whole lot of modeling and a whole lot of overlaying. And actually, we went out to a lot of communities and just said, hey, when it rains, where's the water pond? And can you do anything else with that? Is it an area that's under development pressure or not? And just about every town said, yeah, over off of State Highway 70, there's a wet spot. Never does seem to drain out much. Ding, ding. That's a great opportunity. A, it's aligned with the roadway. And B, it's existing storage that maybe isn't under as much pressure to develop. So this is the little dot. It's a part of St. Mary's watershed west of Fort Worth. And what we did is looked at the timing between existing and future and came up with 6,200 acre feet of storage. An acre foot is a foot of water over an acre of land. So that's a boatload of water that we need to store. And so then we started playing with the models on where can we either reduce that or where can we get the most bang for the buck? And so on one hand, on the left-hand side, they said, well, let's put storage everywhere. And it comes up with, the red is where it's kind of like a heat map. You can get up to about 4,500 acre feet of storage. Not the 6,200 that we need, but it's sure a good start. The other approach is, well, let's do regional storage. And then again, where can we get the most bang for the buck? And it's kind of the same areas to some extent, but there's not as much of them. The other thing that we were trying to do was limit it to public lands so that we didn't have to worry so much about developer issues or concerns, I guess I should say. So one of the other things that we did is we looked at, okay, what happens if we put green infrastructure everywhere? If every road has roadside ditches, if every backyard has a nice little rain garden. And so we did some stacking models, and that's a nice fancy way of saying GIS, of where environmentally sensitive areas were, where we had potential storage, and where the water was going anyway. And so it kind of helped us hone in on some areas where we really thought we could hone in on providing that storage. And here's some more on that. And realistically, that stuff also goes back into that model. I'm working with a whole bunch of engineers that really love their models. And so the question, though, becomes, how do you model a roadside ditch with stage and storage in a hydrologic model? And so that was where we spent a great deal of time trying to quantify how to do that for the models we've got. And we've got some pretty good ideas now. And I'm skipping through because there's another one here. I'm going to skip all of that. So the big thing is to blend and look at things a little bit differently. Normally, as a drainage engineer, if I see a bridge and there's a giant blue floodplain behind it, it's like, oh, that bridge is constricting the flow. I need to make it bigger. Let the water go through. Well, guess what that does to the people downstream? They then flood. And so we have to balance those openings, and we balance both elevation and size so that we can affect the timing on the hydrograph on what gets downstream when. And if we can slow it down enough, the downstream water's already gone when this stuff arrives. The other thing that we're looking at is, are there ways that we can recharge groundwater? Because we're hearing from a lot of our residents, particularly in the South and West, and actually in the North too, they're concerned about availability of water, period. So timeline on our study, we're doing workshops. We're wrapping up the modeling right now. We're getting ready to do a stakeholder, what I call a roadshow. We go talk to some of those small 2,000 person towns and say, what do you think? Will this help? We'll be developing the final products based on the input from those communities and then submitting it to our funding agencies this fall. So we're almost done. So we're looking at raising, I hate this slide because it's an AI image of stormwater infrastructure, and it has no bearing on reality at all, but it's a pretty picture. And it has some good ideas relative to trying to look at how we incorporate drainage into the public space. We look at raising roads, we look at crossings, new roads, buyouts, and trying to better integrate green infrastructure into the built environment as we go. One of the projects, and I'm going to see if I can find it. This one is critical. So you see that dark blue stream going down the middle of this graph? This is in Benbrook, just a little bit south and west of here. And you see those little white squares in that blue? Well, those little white squares were homes that were built in the 50s and 60s. And that blue area is something that we call the floodway, which means it's an area where you have very deep water that is flowing at velocities of 7 to 9 feet per second. That is a significant challenge. And all those other homes that are not in the pink or the blue areas came in after they were built. So this is a really good example of what happens when you don't look at impacts off-site and you're doing your development. So hot pink, existing FEMA floodway, those homes are in trouble. And we finished the modeling on this about the time of the Hill Country floods. And they're like, this could be another hill country in our part of the world. We've since been working with the city of Benbrook, with FEMA, with Texas Water Development Board, to figure out how to address this situation for these homes. They bought their homes in the 50s. It was great then. It's not great now. And so we're like really going through the models to see how many other areas like this we have. Our project is largely preventative. We're trying to prevent this from happening in the future. But we found a situation that's happening now that we have to address. So one of the things we're thinking is maybe we can do buyouts. But you know how expensive real estate is, and there's about 60 homes that are affected. The other thing is, we started Google Maps over time is a wonderful tool. We went back in time. to look at what the historic images are in this particular area. And there was a huge flood in 1922, maybe 100 years ago, but it can happen again. One of the other projects we're looking at, and I like this project just because it reflects the integration. Tarrant Regional Water District has been looking at Mary's Creek all along. It is what hydrologists call really flashy, which means as soon as it rains, the water runs off and it peaks very quickly. And so you have literally a flood wave that passes through the system. And so they were already looking at ways of holding on to that water to use it for drinking water, potentially, and to prevent flooding in their system. And so they started looking at this reservoir, and it's a great idea. Well, then we're sitting in a meeting where we coordinate with the transportation folks, and one of the transportation planners is like, oh, we've got a corridor on our comprehensive plan in that area. I wonder if we could just scoot it over a little bit. That way they don't have to do a big bridge and it becomes the top of the dam. And so this is precisely the kind of thing that we're looking at, where, not that we're putting dams everywhere, but where do we have opportunities where a project can meet more than one objective. And they're also looking at a very large reservoir area with recreational opportunities and green infrastructure. So that's where it is in the world. And so it's part of an overall system. So throughout the whole study area, we're not looking at just green infrastructure or just reservoirs or just culverts or whatever. We're looking at a mix of what can we do to reduce flooding and to maintain quality of life for the folks. And to be honest, to support ongoing development. Can we develop in a smarter way? So that's the project. It's in the funding. And I'm not going to talk about valley loss. So the other thing is we've got policies. And before I worked for a city, I never really got why policies were special. Now I know, because it's one way of making people do stuff that they ordinarily wouldn't think about doing. So we have a corridor development program at the COG. And what that is a bunch of communities that say, okay, we all agree that we're not going to let any development happen that raises the floodplain in the river. Not a tenth of a foot, not a hundredth of a foot, doesn't raise it, zero. And they all sign off on it. And so when somebody comes in that is doing a project like that, they send the model to actually they get a model from the Corps, so everybody's modeling on the same system. They add their project, give it back to the Corps. The Corps says, yeah, it looks okay. Or the Corps says, yeah, you're good, but in this reach here, you've got 40 hundredths of a tenth of a foot of rise. Then the other cities are like, nope, sorry. And so it helps. The other thing that we're looking at is flood early warning systems. The acronym is FUSE, but it's really more. And that's huge. And that is, it's not the only thing, but it is certainly a layer that helps. And the reason I think it's critical is because we've got a situation now where we have that 40% increase in flooding in areas that aren't supposed to flood. So, So the other thing that we're doing is, remember I said there were like some 200 cities of about 2,000 people each. They can't afford consultants. They can't afford and are nervous about writing codes to help address the development that's coming. And so we're building a library of existing codes and resolutions from other cities that they can use. It gives them a place to start from. It gives them people to talk to about what were you considering when you did this. And from a COG standpoint, there's some level of consistency from city to city within the same watershed. I will also say that anybody can use these. You don't have to be in this project area. It would be helpful. In fact, we've had people from the East Fork Trinity River show up at our meetings because they wanted access to the information that we're coming up with. we're also looking at model code for developments. Floodplain ordinances. And I think I'm going to close out fairly quickly. So it's a multi-purpose approach. It is a multi-stakeholder approach. We're recognizing one size doesn't fit all, and one solution isn't appropriate for all. We are trying to better integrate transportation and environment, and it's really interesting. We went to a meeting recently with TxDOT, and we were a little concerned about their take with us messing around with their bridges and such. Turns out they're doing their own resilience plan and looking at challenges around flooding near their roads and bridges. And so what we're doing is consistent with what the state's doing. We're really helping each other on this. And so I think it provides us a lot better standing as we look towards a fairly uncertain future. And state flood plan just came out last week. No, it's out. The water plan for drinking water just came out last week. So good reading if you have insomnia. The other thing that we noticed is Fort Worth is working on an ordinance right now with Valley Storage. Valley Storage is the place, we got in a funny argument when I was at the city of Dallas. So we were trying to increase storage in the floodplain. Well, the gentleman that operates the floodplain was like, oh no, you're not gonna store stuff in the floodplain. You can't do, and he was thinking storage of stuff in the floodplain was like piles of rock and dirt. And we were thinking that it was nice holes where the water could go and sit until the flood wave goes away. So that said, we do know that the constructed wetlands that the Dallas and the Corps installed in the Trinity below the city of Dallas resulted in a 4-foot drop in flood elevation in some of the neighborhoods below that point. And so we do know that valley storage is critical. We do know that it is not really recognized for the benefits it provides. I'm trying to think. I think that's about it. And I don't know how much time I have. Oh, if you want more, if you really want to dive in, we have a story map that explains it, has all the mapping, all the public meetings. This is our website. Again, if you're struggling with insomnia, it's a great place to go. Seriously, it's a lot of really, really good work. I think it's going to be copied other places. We focused on the upstream areas because we felt like it could help the main stem, which is the part that's already built up, first. But we're certainly looking at the lessons learned relative to how to develop smarter would go anywhere in the city, anywhere in the counties around the city. And so if you also want more and you're a glutton for meetings, we have a traveling roadshow and y'all are invited. And that's it.